say Naples to Elgin from a bearing of, then that means at Naples, you've got to put your north, south, east, west line. Okay? How to draw a bearing of 316. A bearing of 316 means from due north. So start up here at due north. Here's 90. Here's 180. Here's 270. Here's 316. Okay? Now, first question is, how can we find this angle right here that's inside the triangle? How do we find this little angle right here? Raise, please. Leah? 90 minus?
Not 46. 90 minus. Okay, so you take 90 minus 16.
Where are you getting 16?
Oh, wait. Minus 46.
Where are you getting 46?
Because the third quadrant, or like the third bearing line would be 270. So
Okay, so I agree. 90, 180, 270. And we're at 316. So you need to find out how far past 270 is 316. So on your calculator, do 316 minus 270. And see what you get. And I think Leah already told us. Did everybody get 46, gang?
Yeah.
Yeah.
Max got 46.
Max, there's no decimals thus far. Okay. All right. Then 500 kilometers I already have in there for you. Okay. Now we're at Elgin. The plane then flies 720 kilometers from Elgin to Canton. Elgin to Canton. Find the bearing of the flight from Elgin to Canton. From Elgin. So as soon as I say from Elgin and the word bearing, you know what you got to draw up here. So draw your new north, south, east, west. Okie dokie. Now, at this moment, okay, can you guys find for me this angle right there? So somebody have the math we would do? Anybody have the math, Kayla? Very good. So now we're going to find this angle right here. So 90 minus 46, 44. If I turn my picture this way, anybody know why I wanted to find that 44?
Because it's congruent. Oh, opposite sides. No.
Why do I need that 44? Alternate interior angles. If this north-south line is, or I'm sorry, this east-west is parallel to this east-west, then Leah's saying that this 44 is alternate interior with this angle right here. Everybody see alternate interior? AIAs? All right, so we're going to put right here 44. Okay? Why do we need that 44? Is because their question is, from due north at Elgin, sorry, I'm too high. From due north at Elgin, they want to know that red bearing. Okay? So we know part of the angle is 44. What we have to do is find the other part of the angle. And then we'll know this whole angle. Okay? We already know from here to here is 180, right, guys? So we just really have to find this little piece right here, don't we? Okay, so we are given, let's see what we're given. We are given side, side, angle. If we read it clockwise, side, side, angle. So, what law do we use, guys, for SSA?
Sine.
Law of sines, okay? And this is actually big S, little s, a, so that's a good thing, okay? All right, set us up in law of sines. Anybody want to set us up? And what we're going to be doing is finding, we're going to call this angle big C. So we're going to find angle big C. So can somebody set us up? Go ahead, Leah.
Sine of 46 over 720 equals sine of
C?
over 500.
Not a girl. Okay. So go ahead and find angle C, guys. Is that going to help us find this little angle right there? Go, Leah.
180 minus 30 minus 46 minus 44, which equals 60.
Yeah. Yeah. So you're saying all three of these add up to 180?
Yeah.
All right. So Leah says take 180 on your calc, minus 30, minus 46, minus this piece of it, which is 44. Oops.
And then 60 plus 44 equals 100.
Yeah. Okay. Good. So this came out to be 60. Right? So the bearing from Elgin to Canton starts due north. We know here's 180, so Leah said now do 180 plus 60, and what did you get, Leah?
240.
240 degrees. And you don't have to say like east of north and that kind of thing, so don't worry.
Wait. Why do you
Set it up. Yes, ma'am.
Do you think like math field trips you go like in reverse game?
Oh, there you go. Field trip. That makes sense for this problem. I'll ponder that. On a baseball diamond with 90-foot sides. All right, put in your sides. Okay. The pitcher's mound is 60.5 feet from home plate. So here's the pitcher's mound, P. And it's 60.5. How far is it from the pitcher's mound to third base? Let's call that X. So they want us to find X. Now, can we assume that this is 90 degrees right here?
Yes.
Okay, so this is 90 degrees right here. Okay. Can we assume that this 90 is bisected into two equal angles right here? Yes. So this angle is 45. Okay. Now, take a look. That's an ugly 90 right there. Take a look at your acronym, and then we'll figure out what we can find, okay? I shall point. You read the acronym, Brianna.
Side, angle, side.
All right, so which law do we use for side, angle, side?
Also,
Law of cosines, and the law of cosines will help us find the side opposite the angle. Okay? All right, anybody so confident, besides Leah, who's been talking to me all morning, which I love talking to Leah, but anybody feel confident to set these up in law of cosines? Remy. Go, Remy.
Okay, so it would be x squared equals 90 squared plus 60.5 squared minus 2 times 90 times 60.5 times cosine of 45.
Very good. All right, punch like the maniacs that you really are. Okay, now, I didn't do 2 and 3 with you on purpose, because I want you guys to take a couple minutes, and with your group, I want you to tackle 2 and 3. Okay. In number 2, they want to find the distance of the fire from each tower. So I named this distance X. Oh, I'm sorry. I named this distance X, and I named this distance Y, and you guys have to find both of those.